Hey kids, this is Mr. Bickford, and this is the start of our last chapter of the year. Chapter 12 is called Statistical Displays. There's quite a bit of overlap with Chapter 12 to Chapter 11, which I think you will see. But let's get started with Lesson 1. Lesson 1, you're going to learn about line plots or dot plots, which actually you have already seen these in Chapter 11. So a lot of this lesson is repeat. But first, let's write down line plot, also known as a dot plot. You can either term, same thing. Line plot, same thing as a dot plot. So a line plot is a visual display of a distribution of data where each data value is shown as a dot or an X. Okay, so there is the definition of a line plot or a dot plot. It's a visual display of a distribution of data where each data value is a dot or an X. So that word distribution, it's kind of a big word, but you can think of that as just a set of data. It's another, you could plug in the word set would work there. So let's look at an example. Let's say that I surveyed 15 students and I ask, how many pets do you have in your house? And I get the following numbers. So here's the question, how many pets? How many pets do you have? And I get the following responses. First kid says 4. Then I get a 0, a 1, a 2, another 0. I ask the 6th kid and I get a 1. The next kid a 0. The next kid a 2. Next kid a 1. Next kid a 2. And the last 5 kids respond 3, 2, 3, 2, 1. So here's a distribution of data, or a set of data. So I asked 15 students, how many pets do you have at home? And this is the responses that I got. So a line plot is a visual representation of this data. So let's create that now. So the first thing we're going to have is a line. And I'm going to look at my data and I see that it goes from 0 to 4. So I'm going to label 0, 1, 2, 3, 4. So here's my line. Now what I do to create a dot plot or a line plot is I'm going to go through the data and I'm going to record either with an X or a dot that value. So the first number, and I'm going to be careful to keep track because again the biggest mistake you're going to make with working with a set of data is you're going to miss a number, skip a number, or accidentally repeat a number. So I've got a 4. And I'm going to use X's on this one. So I'm going to say whoops, that's 5. I almost made a mistake right away. So 4, I'm going to put an X right here. Then I've got a 0. So I'm going to put an X right there. A 1, 2, a 0. So one thing I want to point out is that these X's, the first X of each number, should be in a line. Then I've got a 1. Another 0, a 2, a 1, another 2, a 3, a 2, a 3, another 2, and a 1. So this is a visual representation of my data, a line plot. One quick check that I could make to reassure myself that the graph is correct, that my line plot is correct, is count these. How many data values do I have? 5, 10, 15. I should have 15 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I do. So this is a representation of this data, and when you have a line plot or a dot plot, some things are really easy to see. I can easily see how my data, my low is 0, my high is 4, and I can get that from here, but sometimes depending on the numbers it takes a while to look through there. But if it's in a line plot, it's very easy to see. There's my maximum, there's my minimum. It's also very easy to spot the mode. Which number has the tallest stack of x's is 2. So 2 is my mode. It shows up 5 times. I can get that again from here, but it's just much more easily seen right away from a line plot or a dot plot. So presenting your data visually has some advantages as to just a big blob of numbers. Okay, before we do another practice question, your hidden treasure for lesson 1 is parallel lines. And the word parallel is spelled P-A-R-A-L-L-E-L. And again, it's pronounced parallel. So the hidden treasure is explain and give an example of what are parallel lines. Okay. For this next example, we are going to do, as well as create a dot plot, we're going to find measures of variability and measures of center from a set of data. So in this next example, I surveyed kids that went to a summer camp, and I asked them, how long was your summer camp? And this is what? So length of camp. And this is the data that I got back. Okay, so first kid said 7, next kid said 7, so those are week-long camps. The next kid said 12, 10, 5, another 10, a 5, a 7, a 10, a 9, 7, 9, 6, 10, 5, 8, 7, and 8. So I interviewed 5, 10, 15, 16, 17, 18 kids, and this is how long their summer camps were. So from that, we're going to make a line plot. So make a line plot or dot plot, and from that we are going to find, now I'm going to abbreviate, measures of center, and we are also going to find measures of variability. So those are from last chapter, chapter 11. So the measures of center, again, remember, are the mean, median, and mode. Measures of variability are the range, the quartiles, the interquartile range, and also outliers. So we're going to get all of this stuff from our dot plot. And I want to go back and highlight one thing that we started with. So line plot, this lesson is all about line plots or dot plots. Alright, so I'm going to need a line again. So I'm going to start with a line. Let's see, I want to put my line, I think right about here is good. And I'm going to look at my data, and I see that I believe my smallest number is a 5, and my biggest number is a 12. So from that, I'm going to make my line 4, 5, 6, 7, 8, 9, 10. Okay, so I will be able to fit my line plot or dot plot on that because I've got smallest is a 5 and biggest number is a 12. Okay, so just like I did before, I'm going to go through my numbers very carefully. So 2 7s. This time I'm going to use a dot instead of an X. So 2 7s, I've got a dot here, I've got a dot here. 12, 10, and a 5. So 12, 10, and a 5. So I've done this row. 10, 5, 7. 10, 5, 7. 10, 9. 7, 9, 6. 10, 5. And 8, 7, 8. So 8, 7, and 8. So here's my data. Here is my data represented on a dot plot. And I had 18 values. Let's make sure we've got 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Good. So dot plot for my data, and now let's look at measures of center. So again, the measures of center, one of them is the mean or the average. So I'm not going to write this all out, but I'm just going to tell you how we would find the mean or the average. We're going to add all these values. So using a calculator, I would type in 5 plus 5 plus 5 plus 6 plus 7 plus 7 plus 7 plus 7 plus 7, entering in all the values, and I would divide by how many there are. So when I total that up, all the data, I would get 142 divided by 18. And I type that in my calculator, and the mean or the average comes to 7.9. Next, median. Remember, the median is the very middle of your data after it's in order least to greatest. So I'm not going to write, I definitely could make a list of all the numbers 5, 5, 5, 6, 7, 7, 7. I could list them all out. But I'm actually going to use my dot plot to find the very middle. And so I'm going to get a highlighter here. I'm going to use purple. And I'm going to mark off dots on the dot plot to get to the very middle. And I know there's 18. So that means I know that there's going to be 2 in the very middle. I'm going to cross off 7. So 1, 2, 3, 4, 5, 6, 7. Actually, I'm going to cross off 8 because I know that there's 18 total. So 9 is halfway. So there's 8. Now I'm going to cross off 8 starting at the high value. 1, 2, 3, 4, 5, 6, 7, 8. So I know these 2 dots are in the very middle. And again, I could have listed them in order, but I know that those 2 are the very middle, 7 and 8. And when you have 2 in the very middle, then you have to add those 2 together and divide by 2. So I'm going to do that. 7 plus 8 divided by 2. Well, that's 15 divided by 2 is 7.5. So my median is 7.5. Mode. Again, the mode is which value occurs most often. Super easy to see what the mode is when you have a dot plot. What's my highest stack of dots is 7. 7 occurred 1, 2, 3, 4, 5 times. So my mode is 7. Okay, so now let's move on to, so those are measures of center, mean, median, and mode from chapter 11. Next, we're going to find measures of variability. So one measure of variability is the range. What is the total spread of your data from high to low? So to find the range, my highest value is 12. Subtract my lowest value, which is 5. So the range of my data is 7. It spans 7 units. Okay, next, the interquartile range. To find the interquartile range, we have to first find quartile 1 and quartile 2. And just as a reminder, the way we do that is you have quartile 1 is the very middle of the lower half of your data, and quartile 3 is the very middle of the upper half of your data. So I'm going to cover up, and I don't count the median. The median is not part of this. My median is 7.5, okay, and I got that from this 7 and this 8 together. But 7 and 8 are these two that I've circled. Those are not the median. My median is 7.5. So I'm going to cover up that. There's my lower data right there. So I want the very middle of that. So I'm going to use a pink highlighter, and I'm going to cross out 1, 2, 3, 1, 2, 3. I'm going to cross out this one and this one, and here is quartile 1. It's the very middle of the lower half of my data. So now I know that quartile 1 is a 7. Now I'm going to look at the upper half of my data. So I'm going to cover up the lower half, and I'm going to cross out till I get to the middle of my upper half of data. So 1, 2, 3, 4. 1, 2, 3, 4. Here is the very middle of my upper half of data. So that is quartile 3. So now I can write those down. Quartile 1, Q1 was 7. Q1 equals 7, and Q3 equals 10. So now I can figure out the interquartile range, which is Q3 subtract Q1. So 10 subtract 7 is 3. My interquartile range is 3. Last thing I'm going to do is I'm going to use that interquartile range to check for outliers. Remember, once you find the interquartile range, you multiply it by 1.5. It's always a time and a half. So that's the last thing I'm going to do. 3 times 1.5, the answer to that is 4.5. That is the number I'm checking to see, do I have outliers beyond 4.5 from each quartile? So this is what I'm doing to figure that out. I go back to Q3. I'm at 10. So Q3 is 10. And I'm going to go out 4.5. So if I start at 10 and I go out 4.5, I would be at 14.5. Do I have any outliers beyond 14.5? Well, the answer is no. The highest value I have is 12. So I don't have any outliers on the high end. I do the same thing from Q1, but this time I go 4.5 in that direction. So Q1 is 7. So this is 7. And I want to go 4.5 in that direction from 7. Well, if I take 7 and I subtract 4.5, I'm going to be at 2.5. And do I have any values lower than 2.5? Well, the answer is no to that as well, because my lowest value is a 5. So now I know for sure I can say no outliers. Okay, so again, this lesson 1 is a lot of stuff that we've done, and we've actually even seen line plots before, but now you're going to be practicing creating a line plot. You can use X's or dots, and from a line plot, figuring out your measures of center, mean, median, and mode, and measures of variability, range, Q1, Q3, interquartile range, and do you have any outliers? Okay, that does it for lesson 1. I will see you very soon for lesson 2.